real single-phase transformer models and circuit tests. Hello everyone, my name is Rafael. I am an electrical engineer, and in this video I would like to debate with you real single-phase transformer models and circuit tests. And to do so, I chose this exercise. I am going to read the exercise for our debate. Real single-phase transformer models and circuit tests. The exercise. The equivalent circuit impedances of a 20 kVA, 8,240 volts, 60 Hz transformer are to be determined. The open circuit test and the short circuit test were performed on the primary side, and the following data were taken. Data for the open circuit test and data for the short circuit test. And the exercise asks us, find the impedances of the approximate equivalent circuit to refer to the primary side. So this is what we need. We are going to find this equivalent circuit referred to the primary side. Okay, let's do it. Let's do it, folks. The solution. First of all, let's work with the open circuit test. And the open circuit test provides the excitation admittance. And through the excitation admittance, we find RC and XM. Let's go. The excitation admittance, YE, is the division between the current of the open circuit test by the voltage of the open circuit test in an angle. We are going to call this angle negative theta. Okay? This is standard. Where theta is the inverse cosine of POC, the power of the open circuit test, divided by the voltage times the current. Okay? All we need to do now is to use the values. Simply, consequently, IOC divided by VOC will be equal to this number here divided by this number here. If you use your calculator, you are going to find 0.0000268. This is the mole or Siemens. Which is the inverse of ohm. And the angle, we simply use these values here. VOC here, IOC here, and POC here. And then we take the inverse cosine of this, and we find that theta is equal to 76.5 degrees. Okay? And then we find afterwards, I'm going to erase it here, and then we find afterwards then the excitation admittance is equal to 0.00000268 in the phase negative 76.5. Okay? Moreover, we need to notice that this is equal to 1 over RC minus J 1 over XM. Therefore, using we are going to have to use to convert this polar form into the Cartesian form. Okay, we're going to do this. Okay, 1 over RC minus J 1 over XM will be equal, converting this to the Cartesian form, we get 0.0000050 minus J 0.0000261. And then 1 over RC is equal to this. And minus J1 over XM is equal to this. And if we invert this, we get RC equal to 159 K ohm and XM equal to 38.4 kilo ohms. All right. RC 159 kilo ohms and XM 38.4 kilo ohms. Up to this point, we've solved the half of the problem. Now we need to find the equivalent series resistance and the equivalent series reactance. Let's go, let's do it! To find these terms here, we need to use the short circuit test. And the short circuit test will provide the series impedance. And how do we find the series impedance? We simply use ZSE equal to the division between the series voltage and the series current. Okay, this value and this value in an angle. We are going to call this angle here just to distinguish phi. Okay, for the open circuit test we use theta. Here we're going to use phi, where phi is equal to the inverse cosine PSC over VSC times ISC. And we're going to simply use the values as we did before. VSC divided by ISC is going to be equal to the division between 489 volts and 2.5 amperes. And then we find 195.6 ohms. And the angle phi will be equal to, we can simply use for PSC 240, for VSC 489, for ISC 2.5, and then we find that we take the inverse cosine and we find 78.7 degrees. Okay, and then we get that ZSC is equal to 195.6 in the phase 78.7 degrees ohms, and we break this number apart by converting from the polar form to the Cartesian form, and we find that ZSC is equal to 38.4 plus J 192 ohms. And our ultimate conclusion is that this is 38.4 ohms and this is 192 ohms. Okay, my friends, this is the exercise that I wanted to show you. I hope you guys enjoyed it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye.